Hello everyone. Uh, okay, this is the. If people know that this is the last class, and after that you have exam. So in this class we will solve various questions based on organic transformations, and those are based on previous year questions of various competitive exams. So if you have any doubt in the question solving, then you can ask me. And this as this is the last class, so I your feedback is very important for me also. And actually if people are not attending classes also, that is so. If you will attend the classes, then I think we can discuss more, and we can actually I also get some motivation um, to teach you means regarding this doubt solving session. So that's fine. If anyone is listening this video, so I will tell that if you people try to join and attend the class, then I think it is helpful for that person who is teaching you. And you can, if you are benefited from my lecture, and please give the, I think in NPTEL submitted some feedback form. You please fill that form, and so that we can discuss this thing in future, maybe any other course. Okay, that's all from my side, and best of luck for exam. And okay, let's today begin the class. And as usual, I solve this question, and please try to understand how to solve this thing. It's not if actually this the motive of this class is not to means solve. I can't give all the, I can't solve many questions means solve all the questions what may come or not means, but I can. So that I think that is important, how to solve, how to, if you are seeing how to look the question. And in today that organic synthesis, that organic chemistry, that part. And I will show that how to think about that. That much I can do, because all the things I can't solve, that you also know. And if you have any question, then we can solve together. That already I told to you people. So okay, okay, I'm sharing my screen then, and let's start today's class. Hopefully, is it visible to everyone? Okay. And please see that how to solve means. Okay, first question number one. Okay, today I'll provide where they told to define that what is the major product formed in the reaction. Okay, let me write the question. What is the major product? Sorry. Major product of the reaction, and I am giving a. They provided one reaction. This is the reaction. The reagents are iodine, potassium iodide. I think you people aware of this reason. That's why I give this, I raise this question, and I am give, and we have to find that what is the major product. And this question came, by the way, June, yes, net June 2011, and they gave options. It's also important to what the options they are giving, because sometimes we may confuse. That's why I'm providing you the options also, so that if this type of question comes, then you can know how to solve. Exact question may not come, but a similar type of question can come based on the um, topic and the theory also. You are seeing now here two, these are in the below position. Here one is below and another is up. And another thing they are providing, 1 minute, let me check once if recording is going on or not. Yeah, everything is fine. Sorry, this is the third option. Fourth option is they gave these options. See down below is, and they asked this one. This is attached. Okay. What is the major product? And you have to find among these four options. So how to solve this question? First, what the things, whenever you are solving any question, first things that what reagents they are providing. First they provided one by one. Don't go in hurry or confuse yourself. One by one you reagent and put and see what things are happening. Means first they added potassium iodide and iodide. This is a similar reaction with sir already discussed. Br2 and HBr. What kind of reaction with alkene? This type of H three member ring is forming and it is already strained, and this is bromine is also a positive discharge. So another bromide will attack in the from the below side, because upper side, if we consider this is a upper, it is in the upper side, means bromine is attached with the, so upper side is blocked, so there is only one option to the Br minus to attack it from the below. So this is the concept. Okay, concept. Based on this concept, they ask this question, and this bromide will be bigger. So, okay, let me change the pen color. So what to do first? First, you draw the structure. Here and iodine, potassium iodide. I saw the similar reaction. So what will happen here? This uh, three center ring will form with iodine in we are considering that this is forming the above. You can consider it in the below. Why I am considering it in the above? Mm, that is my choice. Means if okay, I will show you that if you choose in the below na, then also you will get the same question, same answer. Because if we are, because it is, they didn't mention the stereochemistry of this group. If it is the above, then we can tell that it can be below, because then it don't want to face the steric interaction of this group, but they didn't provide anything. So and they are not concerned about of this bond stereochemistry. So I'm just for simplicity I'm just taking it, I didn't attach as the above portion, so it is the, this is forming 300, and this is trained system, it doesn't want to be in that system. So potassium iodide minus we attack from the below side. Okay, so what should be our product? So below iodide, above iodide. Okay, I think this is fine. Okay. Now, one thing you have to be careful. Okay. Let's see these two reagents they are giving. Okay. First, iodine and potassium iodide. Iodine potassium iodide will form that three-centered ring. So, and they are adding base also. So, which one will prefer to attack? Means there are two possible. Now, it is the without base. Without base. Without base means there is no possibility of deprotonation. So, without base, it is fine. So, whenever they are adding base, means what they are telling means they are adding base and this proton is acidic in highly acidic, so in place of base it will be deprotonated. Okay, it will be deprotonated. Now there are two possibilities, this will attack or this will attack. Now you know the this is, if it attacks it is a intramolecular reaction and it is attacks in the intermolecular reaction. Intramolecular reactions are always faster and this is entropically also favorable intramolecular reaction. And so that's why that first all the intramolecular reaction will happen. So this will attack here and here. You can also argue why I told now why it is not happening here because they are adding base. It will deprotonate and it reaction always tries to favor in intramolecular as it is a entropically favorable reaction. And they are also close proximity also in the solvent ions are also floating. So there is a statistical thing for attacking the nucleophile, but there is no statistics for that this intramolecular reaction. So these two you can take it as a reason, or there are other reasons also. But that's why that intramolecular reaction is favoring. So don't be confused with this. For solving these things, many people do the mistake. They do this kind of answer, but it will not happen because you have to taken care of what are I. That's why I'm telling what reasons they are adding. You have to look carefully. This is a trick. Means that's why they asked the question. Na? Base intramolecular reaction happens. So this O minus will be attacking from the below side as it is in the upper. Okay, if it is in the upper, iodine will be upper and O will be below. Anyway, okay, okay. So further things will form here. One carbon, double bond O here. Now we'll see the options. This is our work. Till now we did. Now we have to match with the option. What option want to know from us? So these two will be. So what we got? This iodide and this group has to be trans. Here you can see that means anti, not trans, anti. So anti is the base nomenclature for this. So here you can see that here iodide and this iodide are in anti position. Okay, and here you can see, okay, if iodide is above, this will be below. Okay, now for the things below above. If it is the if, but here you can see this hydrogen is below. This hydrogen below means this one will be the upper. Okay, so you can see that these two are in syn configuration, and here this is a different product. Here there is no intermolecular reaction transfer. So we have to check between these two things. So here we can see that this iodide and these are the anti and these are the syn. And what products we are getting? Here these two are anti, so what will be our product? This one will be our product. Just whenever after solving the after doing the reaction, you also have to check with what option they want. Sometimes they is the stereochemistry that has to be, you have to be very careful. Here they just means wanted to know what is the stereochemistry of this O and iodide. That's why they gave two options. This is very important. I think hopefully it is understandable to anyone, everyone. If you have any question, you can ask me. If you don't have, then I will move forward. I'll move to the next question. Okay, this one will be a product. No question. Then I am moving to the next question. Second question. What is the second question? 1 minute. Yeah. Similar type of question as the reaction. They wanted to know the reaction they provided, and they wanted to know what is the reaction intermediate. Okay. Reaction intermediate. Reaction intermediate. The reaction is this one. In potassium iodide. Here also they used mild base. So you can, okay, that product you can also see that that intermolecular reaction is happening. They also give that product also, and they wanted to know that what is the intermediate. Okay, this is the product they are providing. This is the similar type of question what I had discussed. I just wanted to know whether you people are understanding or not. That's why I'm just gave this question. Okay. So how to solve this? Okay, I will give that options also. I think that will be helpful us. The options are, first option is the this iodine is the above of the plane of the ring. Here you can see that COO means that hydrogen is getting abstracted, but it will not be okay. That I previous question I discussed. Whenever you are adding base, it will be protonated. In intramolecular reaction will happen. I already discussed in the previous question. So and this is the below. Okay. Third option is this is the above, okay, and their cation formation. And third option is this one below. Okay. So can anyone tell me what will be the answer? I already discussed in the concept I discussed. So if anyone can tell, that will be. I already saw the intermediate also in the previous question. They also providing the product. Here we can see also. Okay, I'm giving some hints. Okay, how to solve this question? Okay. First off, we have to look that iodide is the in the product, iodide is in the above. So that the three-member ring will form. It will be in the above plane of the ring. So among them, there are two possibilities, this one or this one. So here the three-member ring is forming, here not forming. So what is the intermediate of this reaction? Can anyone? I already discussed this concept just 1 or 2 minutes before. Okay, no one, then I'll solve this. This one will be the answer I previously saw. Now I will. I think it's better to show the mechanism how it's reacting. I think that will be better. CWNA. This one you are getting that CWNA that you are using base, mild base, and alkene. Okay. Okay. So you can see the iodine bond is there. So there is a electron density. Alkene is there, and how to break this bond? It has to transfer the electron in the sigma star orbital. Generally, if you don't think in that way also, to break this bond, it has to transfer the electron here. Then it will break, na. So it has a tendency to accept, and it has a tendency to give. So it will give the electron here in this. Arrow means here I am giving arrow means it's transferring to the sigma star orbital. Okay, this you have to be very careful. Arrow also. Okay, here I think sigma star orbital, because this only atom can't take, because we have to break this bond now. So it will transfer sigma. If two electron is there, sigma star it will have it wanted to take two electron, then bond order will be 0. So it will take two electron, then it will break this bond. So now what will form? This will form. And as they are giving in the product is added in the upper, so I am just showing the upper portion. Okay, and there is another thing is it is in the below, and it doesn't want to face steric interaction also, so it's attacking from the above side. And so after attacking, it can easy these are the close proximity, and it can attack here, and it will form the product, that expected product, the product they provided only. Okay, hopefully it is understandable to all. I think we will get it. If you have any question, you can ask me, or otherwise I will move to my next question. Okay. Now I am giving a very general question. So you have to solve it. How to solve? Every question you have to look in a different means how you are looking the question, that is very important actually. I mean what the why reaction will happen, and where that attack happen. These things you have to, that because reaction doesn't happen normally. It has to give some driving force to means to follow the reaction, to move the reaction in the forward direction. So why the reaction will happen? It is the system will get some stabilization. The intermediate is little bit unstable. Means it passes through the intermediate. So intermediate means higher in energy than that of the product. So means, but if we keep whenever we wanted to know which intermediate will form, all time we have to check which intermediate is more stable. Otherwise, why reaction will happen? This is because this is very important to solve the question actually. That's why sorry, THF solvent, and this I think this is very this I think you could able to answer this question, because this is not that much tricky. Second options they provided. Second option Third option accepting. Okay, this question you can easily solve it. Can anyone solve it? What is the idea behind this? Sodium hydride we are giving. So what will happen? We are always telling for the reaction and get stabilized. Means you are giving some reagent that intermediate will form that will has to be stabilized. So that the energy of activation will be ratio. Okay. Okay, they are giving okay, I am solving that. They are giving sodium hydride. Okay. So now we will see hydrate. Hydrate we are giving. So among them, hydrate we are giving. Among them we have to see which proton is much more acidic. Okay. If you see the acidity, first of all, there are okay one by one. First of all, whenever this agent is giving, so it is coming in the mind that it will abstract the proton. So now we have to see that which proton will be abstract. Okay. So here all the things we know are common concept aromaticity. I think all people will know. So here between these two rings, this ring is already aromatic. Here we can see that this is the sp3 carbon. Okay. If we abstract one proton from here, what will be the system? This one will be the system. And this is now whole conjugation is happening now. The whole system is aromatic in nature, and this is the driving force of the reaction. Okay, these things you have to taken care of while solving this question. As you people are reading it for the first time, so these little things you have to know. Then you can get more idea in the when you will go in the masters. Then I think that you will get more idea about these reactions. But I think for bachelor's course, you have to just focus on the concepts. Okay, here so what the things sodium hydride, protons and H minus and H plus are originated. Okay, so now the system is getting stabilized. Aromaticity is another factor, and you can see that whole the system is resonance stabilized by. Okay, and now if you see the other options here, now you can easily tell that which reaction is happening. Sorry. After proton abstraction, this will be minus. Because it's have that bond having two electron. Okay, and whenever it is liberating as proton, then two electron will be remain, that will be in the carbon atom. And these two means you can see na this is liberated as H plus. So where the two protons will go, sorry, two electrons will go for the carbon H. So it will come here. It will leave the electron here and will fly out as a H plus. So it will form, and now for the things they are providing, these reagent they are providing. Okay. So what the reaction will happen? Here you can do like that also. This is the normal substitution reaction. This is the step you have to take in care. Now this is the normal substitution reaction you'll have to. I think I should write it here. Substitution reaction will happen. Then what will be our product? Let's write once again. So fourth one will be our product. Okay. Now let me add more slides. Okay. Now the next question I am moving. Question number 4. The question is, I think now you people can solve this question. This question is like that. BR2 and MEH. They are providing, okay? And the options say what will be the major product. They asked. They asked about the major product of the reaction. The options they are provided. Here the main thing is the stereochemistry. I think I discussed this concept. I think now you can answer this question fully. Option D is like that. Okay. Okay. If you even give the wrong answer, then also I am fine because it's having some kick that I will discuss. Okay, so then this is the question. Can anyone just tell me what will be the product? This is I think you people should answer this question because this similar concept I already told you. Okay. If no one is answering, then I only have to solve this question. Okay. They bromine and methanol. Okay, good. So what the reaction first will happen? Alkene and bromine is there. I'm considering it. It is in the up. Okay. I'm just considering. You can also you just have to check the stereochemistry. Which one is up? Which one is below? That is, yeah. I think I should show you in two-way also. Two-way only. I think it will be better to understand. Other things you only need to know. Okay. You just have to see that this anti or cis. This thing then based on this you can answer the questions. These two are similar. Sorry. And okay, now okay. There are two possibilities here. There you can also say that methanol is there in the reaction medium. It can attack, and that is in the reaction medium. Okay. Another thing is that this this is having lone pair. It can break this bond. I already told that in the previous discussion that the intramolecular reaction is favorable. If the system wants to do the intramolecular reaction, always it will favor, because that is entropically and statistically favorable also. So this will form here also. I'm just showing. Okay, this reaction will form here. Now the positive charge gone. Here oxygen having 3 bond means it's positively charged. So what about now? Here is positively charged and Br minus in the below. Br is the below and positive charge is neutralized as already given the electrons to nullify this positive charge. Okay. Now you are seeing that systems having highly positively charged oxygen, that is very much unfavorable. Oxygen having high electronegativity, so it doesn't want to be in that situation. So now what the system is having methanol. System is having methanol. So now we have to see that in which side it will attack. Now here the steric thing comes. Br minus in the above. If it tries to attack from the above side, then it has to face the steric interaction with the Br minus, means bromine and sorry bromide. And if it attacks from the below side, then the steric interaction will be less. So if here it is Br minus above side, OMe, it will attack from the below side. So here it is the below, so OMe we attack from the above side. Okay, now what the product we got here? Let's write it here and below. Here, below means OMe. Now we'll check with the question. Okay, sorry, that are options. Here you see these two are Br minus Br minus. This will not go. Here this option we are just looking for this option or this option. These two this okay. There are three options. Okay, among them you know that here OMe will come and Br will come. So what the options left? So this will not these options also cancel out. Okay, here also another thing is there. Okay, here no there is no other thing. So OME I think. Okay, Br minus okay. Option here you can see this will not form, this will not also form. Here we saw that in the product that OME will come here and here, and these are in the, and sometimes they can ask these are the C's position. These things are stereochemistry is very important because some these questions will confuse you, stereochemistry thing. So if also they give that the option that OME and Br, these two groups are in the scene orientation, sorry not scene orientation, then also it will not, will be not our product. Our product will be where their anti. This one, these are two anti, these are two anti. This is the main thing. That's why just I wanted to show you that if the stereochemistry they already provided in the starting material, then you have to first think that where the reaction is going to happen. If the bulk, that it depends on the many factors also. That thing you have to first consider. And here, as they didn't provide any stereochemistry, so we're just considering that it is in the above, and with respect to it, we are means checking the stereochemistry of this another group. Okay. So the main thing is this: these two are anti. these two and so we have to find that product. If they give this product, then also and some you think that you did this way. Yeah, if you thought that beer man is in the positive above and you got this product, okay, then option is this. So don't be confused with this. First thing we have to know that these two are anti. So we have to choose that product that is anti. This is the main important thing. Okay, as they didn't provided any stereochemist of other thing. Okay, this is very very important. And so what will be our product? This will be our product. To the another question. That will be the question. One question I provided. Actually, this type of question comes. That's why I just wanted to. If you have any doubt, you can ask me. You can ask me. Okay. Another question. This is question is very important. Miss, you just have to know the concept only. Okay. They provided this. They will change the stereochemistry. They will move in other way. The things are there. But what things you have to know, 180-degree rotation will not change the stereochemistry. So 180, if they give any structure, means here you can see that OTS in the another direction. You can do the 180-degree rotation with respect to other carbon. So then we can also, then here the main thing is that, okay, first, I think I am moving first off. This is the, let me provide that options, I think that will be helpful. They asked this question, what will be the product and the options they provided. Organic chemistry, na, you can solve any question just by theory. Means here you don't need to know, means you can easily solve it if you know the concept. You just add one reagent. What reagent they are providing, you can solve it. And other factors are also that you have to be taken care of. These are the four options. These are the alkene, okay? These are the alkene. Okay. So let's first draw the species they provided. Was that here MEH, here pH. It's also this is also having one name. Okay, let first I will solve it, then I okay. Here also. Okay. Here you can see that this is a living group, good living group, and it's have the capability of giving the electron. And these two are trans orientation, sorry, anti orientation. So all the things are favoring the substitution. Na? So first thing is let me write, okay. OTS, good living group. pH can acts as nucleophile. And these two groups are pH and OTS groups of anti-orientation. Anti-orientation. Why anti-orientation is more favorable? I think that things sir already discussed in the class. If you not getting that thing, you can ask me also. I can explain that thing. As sir is already discussed, so I am not means discussing it. Okay, so everything is favoring, so it will attack here till leaf. So what intermediate it will form? If you don't get, then please post me before your exam. I will try to solve your queries. But you have to ask. That is the main thing. Okay. As I'm just delocalizing the positive charge over the whole system, as it's giving the electron, it will be positively charged, and it's OTS minus. OTS minus is leaving out. Okay. So now what the systems are providing? Acetic acid, OSC, they are providing. Okay. So this system is highly unfavorable system. It's having a positive charge and having a three-member ring. Okay, angle strain is there. Let me write it in angle strain. So it doesn't want to be in that system. So it wants. So another group is there. And here also stereochemistry is also there. Okay, we are considering it in the up. Here we can see that it is in the up now. So it will attack from the up, and it's below. It will go up. It's in the up. So it's in the up. So below that it will attack. When sir discuss about the substitution reaction, sir already discussed all this concept. If you don't understand, then you can ask. Means why it is attacking from that back side and why the trans anti-orientation, that orbital approach is there. I think if people are aware, if you don't know, then please go through those lectures and it's everything. Or if you don't understand, then you can ask me anytime. That I told you already. That's why NPTEL is sorry. Okay, this arrange this session so that you can clear your doubts. If you're not asking, then okay. So obviously inform. So this will be the product. What will be the product then? OSC and pH distributions. And ME below and H will be up. The options we'll see. We'll have to match actually the options. In one options, hydrogens are here. We can see that this one and this one. Sorry, below. This one above and this one below. Okay, we have to search for that option that is this means one hydrogen is up and all they give two options. I think if you look carefully, in both the cases pH and OME are anti, but these two will cancel. Okay, so these two among these two, what will be our product? Here you can see that these hydrogen, this hydrogen in the same site. This semi in the same site. Here these two are in different. Here what will sorry it will be in the different site. Okay. Here in the product we can also see that this hydrogen in the opposite side. Methyl also in the opposite side. So these things we have to take in care. So what will be our answer? Here you can see that opposite side. So this will be our answer, not this one, okay? These things we have to be very, very careful. I think it's already if you, I was also thinking that I will solve many questions today, but if people are not responding anything, I think okay, okay. Let's tell me something. Okay, this is the last class, and we are meeting for the last time. Okay, and this the motive of this class was to solve your doubts, but you people didn't ask any doubts. So I think I'm hoping that you people know have you don't have any doubt. So your examination is coming. You do well, and if in between, if whenever you will read, that time any question arise in your mind, you post in that NPTL that website is there. That's where you took that course. Okay, that side you post, and another person is just looking that which questions you people are providing. Then if you post, then I will get knowledge that you people are what questions you people are providing. Then I can that solve those questions and make a small session if you people want, and then you people mail in, you can mail in the NPTEL, and I mean, whatever you want to do, just you can arrange a small session so that your doubts can be solved. So that's from my side only. So now it's your call. So yeah, hopefully you people enjoyed this course, and yeah. We can meet in the in any course if in future, if I take any uh, if you take any course and I am the TA of that course, then we'll meet again. Okay, that's from my side. And I told you now I can arrange a small session where you people can bring your doubt, and we can solve them. Okay, it's better if you post little bit early. Then I if I don't get that question currently solved, then I can discuss it there. But obviously in that session I will solve it. Okay. Mm, okay. Okay. Thank you for listening, and thank you for attending this class, and I enjoyed. I think hopefully people also enjoyed. If people not enjoyed, then mm, yeah, this can be my mistake also. But I'll try to improve. It depends on your feedback only. Okay, I think yeah. Bye, bye, people, and best of luck for your exam. Yeah, we can meet in another course maybe. Okay. Okay, I'm ending the session, ending the class for today. And this is the last class, if people know. Okay. Okay, see you. Okay, not see you. Okay, bye, guys. Okay, I'm finishing the class here. Okay, bye. Okay.